Next, let's take a look at common attacks. Know yourself and your enemy, and you will never be imperiled in 100 battles. The nature of attacks is as follows. Firstly, one must understand that no one is immune to attacks. You are not attacked because you are not deemed valuable. Valuable targets will inevitably be attacked sooner or later. This is the reality. Thus, we should not harbor any false hopes. Attackers could be independent individuals, hacker groups, criminal organizations, or perhaps even state government agencies. Do not think that state agencies cannot be attackers. Recently, a university in the western part of our country was attacked by a certain state government agency. This possibility is not impossible, so the attackers might be independent individuals. These independent individuals, right, they could be a certain hacker or a hacker group. Such entities could be hacker organizations or criminal organizations. These criminal organizations or even state government agencies could be the attackers. When it comes to attacks, often they use innovative capabilities. They often innovate in creating new methods. Here they exploit various vulnerabilities and then use various techniques to evolve their attack methods. Find various vulnerabilities, right? Then they continuously evolve their attack techniques. Here they might be motivated by profit. For example, ransomware. Why? For profit. Or it could be specific hacker behaviors, ideological motives, for instance. They simply want to test their newly learned skills. I just learned a new penetration technique. I just want to try it out. That's also a possibility. Or say those, for example, some kind of spy activities, like for instance, various espionage activities, like say several 100,000 cases, those 500,000 personnel. These people, they aim to go to steal information, and like some types of national level cyber warfare and such. In these cases, it means as long as your system is valuable, sooner or later it will encounter an attack. So this thing is, no one can avoid being attacked. You are not attacked because of that. No value. And so people think that attacking you. They think attacking you, even considering the time and cost involved, it's not worth it, so you might not be attacked. But just like what? Just like you say, your bare bones house, right? A bare bones house with nothing inside. That's the thing. You, a bare bones house with nothing inside is just, you just have a wooden door on top, right? You think anyone will come? Will anyone come to rob your Buddha statue? Will they come in? Or will someone come into your bare bones house to steal something? Come in, and will anyone come in to steal things? Indeed, it is of no value. But you say, right, you say in your house, if you had a lot of antiques and paintings, then if someone knew about it, frankly speaking, not to mention your house, including some of those kinds, including some people, right? Even they wouldn't spare someone's grave, let alone if it has value. It will definitely be attacked. So in this regard, speaking of defense against attacks, it's difficult, right? After all, if you want to completely defend against attacks, so-called absolute defense often does not exist. We can only do some mitigation. In this regard, it's about how we can prevent, how we should prevent these attacks. If we encounter an attack, we need to consider how to deal with it, dividing it into preemptive and reactive defenses. Preemptive defense is about preparing ahead. It's not about suspecting that someone will attack my network and I should beat them up. It's not about beating them up. This point means we should construct some secure measures here. For instance, on firewalls, we set rules for traffic to be allowed through, what kind of traffic can pass through the firewall, what kind of traffic can't. Just like setting up a checkpoint, right? For example, between countries at ports, you set a checkpoint. Who can be let through, who can't. You say some come, a few come to the facade. Carrying carrying RPGs, you say, would you let them in? Of course, you wouldn't let them in, right? So this, for example, right, some people, right, they have their regular documentation, everything is normal, not carrying anything, any dangerous goods, right? In this case, we can let them in. These cases are similar to us setting up traffic rules on the firewall. These belong to preemptive defense. What then is so-called reactive defense? This thing is like, for instance, we go to the Ministry of Public Security to check. We go to the website of the Ministry of Public Security to see. There will be many wanted orders, right? These wanted orders belong to reactive defense. You can't say that someone is born and then say, right, I see you were born rebellious, I must arrest you. Usually that's not done. This here isn't done like that. It's definitely this person, right? He did something then go to issue a warrant for him. Of course, that is. Of course, when you open that web page, I remember I saw there were a few people just wanted. It seems for 2 or 3 UN, this kind. Anyway, right. Once they are on that web page, they belong to what? Similar to our setting up a dynamic blacklist in network security, right? This is sort of like, isn't it? A bit like a wanted poster, right? You say this person, right? This person on his way. This person, for instance, he wants to, for instance, go take a high-speed train at the train station. That over there, that security personnel or police, upon seeing this person looks very much like the person on the wanted poster, then of course they stop him, right? First to interrogate. This belongs to what we call reactive defense. Proactive defense is about us first setting up these traffic rules. Reactive defense then refers to, it's generally more targeted. It's about what we target, what kind of targeting certain characteristics to specifically design his security mechanisms. Here we talk about attack phases as pre-attack defense and post-attack defense. Of course, now there's also during the attack, that is to say, pre-attack, during attack, post-attack, when being attacked. Now there's also what? To identify and to record. That is, to identify, to record. For instance, he records it down. The attack, where the attacker is from, where the attacker launched the attack from, which hosts were attacked, where the attacker was. Then, if, for instance, some threats in the network, while spreading, will record these respective paths. He can record the respective paths. These things are recorded. This facilitates us to later trace back, to understand what really happened, where he came from after coming in. He then, for instance, uses which host as a springboard. Or say a virus came in, how did it spread? These then are mainly belong to the phase of attack, right? We can't achieve absolute defense, but we can mitigate through various means. If you talk about absolute defense, it's like cutting it all off, like say we face external threats. You say I unplug the network cable, right? Like say we address these external threats by unplugging the network cable. In that case, you would of course be safe. That way you would be safe, but then your network would also cease to exist. So this issue here is about our attacks. We can mitigate. In mitigating attacks, we definitely need to know one thing, where our vulnerabilities are, right? And then what kind of attack techniques can be used. Here it's said that vulnerabilities can also be called exploits, where we have gaps. Based on these vulnerabilities, we might be susceptible to certain attacks, and we can defend against them using various methods. So, based on these vulnerabilities, we need to be aware of potential attacks and how we can defend using various strategies, right? How do we protect privacy, integrity, availability? Basically, right? Like privacy, for instance, someone trying to steal information. Then integrity, right? Availability. These are targets for others wanting to cause damage. How do we ensure their safety? It's about us. Based on different types of attacks, we need to use different defense strategies to mitigate these vulnerabilities. It's not that, right? Security isn't just about buying a product, like just buying this firewall doesn't make you safe. It's not like that, right? Honestly, right? If you buy this device, if you buy a device and don't use it, it's as if you don't have it. Of course, it's just. Indeed, some companies might buy a firewall, but then the firewall they bought has what inside? Set to allow all, permit any. Permit any? When you do that, it's as good as what? You say it's as if it's not there. I think it's not just that you have an extra point of failure, right? You buy the equipment, you don't use it, you don't go through with this. You say it doesn't have it. It's not that, right? If the firewall fails, it could also affect your network. So this only means doing it this way means you've added a potential failure point to your network instead. It might even be better not to have it at all. Alright, next let's look at what kind of attacks there are. One is DOS attacks and DDoS attacks. A so-called DOS attack, which is denial of service, involves consuming key resources to make your system unusable, like causing your system to crash or saturating your network bandwidth. Making your services inoperable is the goal of such attacks. These kinds of attacks, honestly, are very simple in principle. Just like when someone opens a restaurant and you go in and just sit there. You don't order anything, just sit down and drink tea without ordering any food. This is considered a form of denial of service attack. If you sit in someone's restaurant and just sit there, when the waiter comes over, you say you're still waiting for someone and just continue drinking tea. The waiter comes again, you repeat that you're still waiting. This too is considered a denial of service attack. Why? Because you're occupying their table space and they can't do business. This kind of behavior exemplifies a DDoS attack. A distributed denial of service attack, or DDoS, is when you not only do it yourself, but you also bring a group of people who enter and occupy all the tables in the restaurant. You fill up all their tables, and even then it's not enough. You also take even more action by grabbing a bunch of queue numbers, a few dozen of them. You sit there, and when someone comes to ask, you say you're waiting for someone. After a while, okay, my people didn't come, I'm leaving. After you leave, another number is called up, and someone else sits down, also waiting for someone. This disrupts their ability to do business. So this kind of DDoS attack is basically about preventing them from being able to provide service. You devise ways to make it impossible. A so-called DDoS attack is when you use multiple nodes, for example. What do hackers like to do? Many hackers like to do something called building a botnet, right? A botnet is made up of controlled computers, controlled systems, and of course, some people call these kinds of devices a zombie network. This type of DDoS attack is, in fact, quite prevalent in today's networks. What do they often like to do? You can think of it as a kind of mafia on the internet, how they operate. They first target small businesses, for example. They would approach a small business, for instance. Then they might send an email to a small business saying they are from some security company. Recently, they have discovered that there are attacks occurring in the network. There have been some kind of attacks. Then we can offer you a solution, or we feel we can help you defend against such attacks, and then we give you a few calls. If you ignore them, okay, then they start using the botnets they've commandeered to launch a DDoS attack on you. Let's say, for example, they might fill up your server resources or saturate your network bandwidth so that you are unable to provide normal services, causing your business operations to halt. In such cases, this type of attack, honestly, if you've set up your own systems and network, not hosted in those ITC data centers by ISPs, or not on cloud platforms but rather in your own enterprise data center, encountering this problem, honestly, the lowest cost is just to pay them, right? It's not cybercrime because honestly, trying to mitigate this DDoS traffic is quite troublesome for small businesses. Honestly, it's very troublesome, so there are people who specifically engage in these activities. This type of activity involves DOS and DDoS attacks. This type of attack, honestly speaking, is quite crude. It's just about making you unable to operate. Like we said earlier, you mentioned DOS attacks. I remember someone online said they could eat at Haidilao for a few bucks, and they got severely criticized for it. That person went to Haidilao, right, and ordered a plain water hot pot with some beef granules or something. That's a DOS attack. If you bring a group of friends, say from your school, even pulling in the next class to join you at Haidilao, and everyone does the same, orders just a plain water hot pot, then asks for beef granules and maybe even overdo it by asking them to sing a birthday song. This would be a DDoS attack, a sort of tactic that is difficult to distinguish because when someone walks into your restaurant, how can you know if they're there to eat or just to occupy space? This is the challenge with DOS and DDoS attacks. They just use various methods to occupy your resources and prevent you from providing services. This type of attack simply aims to deny service. It's a denial of service attack, utilizing various methods to keep you from operating effectively. These so-called DDoS attacks are tough to differentiate because sometimes the traffic they generate is hard to distinguish from legitimate traffic, like a person entering your store. How do you know if they're there to dine or just to occupy a seat? You don't know, right? That's the thing about these attacks. They deny service by employing various methods to occupy your resources and prevent you from providing services. That's what these attacks are about. They just want to make it so you can't operate. Okay, so the practical techniques are actually quite varied. For instance, from a protocol perspective, a simple example is the TCP SYN flood attack. A TCP SYN flood attack, as it pertains to the TCP protocol, is about establishing a connection, right? It involves two endpoints. These two endpoints use the TCP protocol to establish an end-to-end connection through a three-way handshake. The first handshake involves a SYN, where the initiator sends a SYN message, then the responder sends a SYN ACK message, and finally the initiator responds with an ACK message, completing the three-way handshake. This way, an end-to-end connection is established. It's like saying, "Hey, hello" to someone. You say hello, and the other person responds, "I got your message, hello." Then you reply, "I got your message," confirming that both parties can communicate. At this point, it's like establishing an end-to-end connection. Now, a SYN flood attack is akin to, let's say you run an online store. You open an online store, and then you open, let's say, a Taobao store, for example. You open it up, and then someone sends you a message saying, "Is the boss there?" You reply, "Yes, I'm here." But then they don't respond. Your chat window stays open while you wait for their reply. Then another person comes and asks, "Is the boss there?" And you say, "Yes, I'm here." Again, they don't respond. Another person asks about a product. "How much is it sold for?" You respond, and again, they don't reply. They just send you a SYN message and don't respond. Then you find yourself with a bunch of open chat windows, only to realize that none of them are genuinely interested in buying. They are just causing trouble. This is what a SYN flood attack is like. They send you a SYN, you send a SYN ACK, and you wait for them to send an ACK back, but they don't. This kind of attack requires a lot of time to deal with engaging in chats, but they aren't really interested in purchasing anything. They're just playing around. This type of scenario is a TCP SYN flood attack. They send you a SYN, you send back a SYN ACK, and you wait for their ACK, but they never send it back. This type of situation is typically easier to defend against if it's from one host. You can just block that host's traffic. But if, for example, it's like an account that keeps bothering you, constantly asking, one account keeps asking you, "How is product A sold?" They keep asking, and it's just one account continually harassing you about product A. You replied, "How is product B sold?" You responded about product C as well. They ask you about everything in your online store. You might think this person is not right in the head. Then you ignore them, which is manageable with one person, but what if a group does this? Isn't that a bit chilling? You say, "Is this easy to defend against?" These types are hard to defend against. DOS attacks are easier to guard against, but DDoS attacks are much more difficult. Or what about UDP flood attacks, right? Besides TCP floods, there are also UDP floods, ICMP floods, IGMP floods, DNS floods, etc. Various protocols can be used for flood attacks. Let's take a look at DOS and DDoS attacks. Here, a DOS attack is usually initiated from a single source, while a DDoS attack involves multiple sources. Imagine you run an online store. A DOS attack is like one account, around the holidays, coming to ask about products A, B, and C. It's easier to defend against, but a DDoS attack involves a group coming to bother you. They come to hassle you just for kicks. This type of attack, DDoS attacks, typically utilize a botnet, or what you might call zombie machines. Attackers often enjoy using penetration techniques to illegally control other people's systems, taking control of those computers, all of which are known as botnets. When they wish to launch a DDoS attack, they typically use these botnets to execute the attack. Identifying the attackers can be quite challenging, and honestly, these types of attacks are quite tricky to deal with. The main difficulty is that it's hard to preemptively guard against them. Another type is spoofing attacks, which appear to come from other systems, but actually, the attacker hides their true identity using fake traffic packets to mislead. Spoofing attacks aren't just any form of attack. They are specifically achieved through technical means. Like when you carry out a DDoS attack, you might use disguises, employing the botnets you've captured. You wouldn't foolishly use your real IP address when sending attack packets, right? I wouldn't do that. If I could use a fake address, I wouldn't use a real one. So DDoS attacks often involve disguising the source IP address. This includes attacks like fragmentation attacks, including things like reflection amplification attacks. Of course, I will elaborate more on these types of attacks shortly. For example, are there any such attacks here? Yes, there are. One of the earliest viruses known was called Smurf. This attack involves using a technique where it forges an IP address. It also uses the ICMP protocol to launch attacks. This method, through ICMP, facilitates the attack. Here, especially in Windows environments, there was a specific vulnerability related to the handling of ping packets. In these cases, the size of the ping packet had a limit, and if the packet was too large, it could cause an overflow. This means that there would be instances like memory overflow, what's known as a buffer overflow. For example, let's say I give an example. Suppose a certain character or attribute, how much is it? Let's put it this way. We have a data structure called TLV, which stands for type, length, value. Type, length, value, right? What type it is, its length, and finally, what the value is. However, this parameter is unrelated to the other parameters, which means, effectively, you're encroaching on the adjacent space, right? This can cause other data anomalies, right? This is what's known as a buffer overflow. With a buffer overflow, what happens is it can cause certain issues, potentially leading to program crashes. Previously, Windows had a bug with its ping command, known as the ping of death. If the packet was too large, it would simply crash the system. It would cause the system to crash outright. Back in the early days, there was a tool, a virus called Smurf, that specifically did this. It would forge ping packets and then crash systems with them. This would result in systems crashing, rendering them unable to provide services. That's the Smurf attack. Source address spoofing is easy to understand, right? In our IP packets, the IP header contains both source and destination addresses. If you spoof the source address, you can commit a lot of mischief, right? That's the case for Smurf attacks. Fragmentation attacks, which are like this. Smurf attacks and fragmentation attacks are essentially Smurf, as I mentioned earlier about fragmentation attacks. Smurf attacks are this type where they're quite nasty and bad. Fragmentation attacks refer to the ping of death, where your ping packet is too large, causing the system to overflow in memory. That's a fragmentation attack. Smurf attacks, however, work like this. Let me illustrate. It works like this. Smurf attacks are, for instance, if you have a network here, within this network, you're connected to many hosts. Many hosts are connected. Then I have an attacker here outside, and after I connect, say, the network segment is 192.168.1.024. Then what happens with the attack? How does it work? For example, the victim on the far right, their address is 192.168.1.100. The attacker will do this. They will forge a packet, a source IP claiming to be 192.168.100, and the destination IP is then. The destination IP is 192.1168.1.25. Pretty malicious, right? Very malicious, because he's saying he uses a forged address to ping broadcast, which is essentially like what a bad guy does when he forges someone's identity to send out invitations pretending to be them, saying they're getting married, and then tells where the wedding will be. Then, his friends run off to a non-existent wedding venue. He's saying the wedding venue is at this place, and then his friends all go to this non-existent venue. This is equivalent to the attacker pinging a broadcast address, which means he's pinging all devices in the network. Broadcast address means pinging all endpoints in the network, and all endpoints must respond back, right? At that moment, it achieves what is called traffic amplification, and he amplifies this traffic. This type of attack is known as the Smurf technique, but if Smurf attacks are combined with other techniques, like combining IP fragmentation, you make it so that or combining these types of Smurf tactics, it's just about using forged principles. He forges the address, forging the victim's address to access others, like accessing the broadcast address. And then, through this, using other devices in the network as amplifiers. Through this, network devices act as amplifiers, thus facilitating the attack. In the early days, this kind of attack was effective, but now it's ineffective, no effect at all, because in Windows, from Windows 7 and above, Win 7 and above systems, what happens is ping is disabled by default. Ping is disabled, meaning in Windows 7 or in that version of Windows, Windows Server 2008, and later systems also have ping disabled by default. Meaning, if you were on XP or 2003 systems, you could ping a host by default. That's how you could ping back then. But now, these hosts, by default, do not allow pinging. Why? Because if you disable ping, you can prevent such attacks. Meaning, your computer won't be easily used as an amplifier to attack other hosts. So, this kind of fragmentation attack, where you send overly large ping packets, causing some older systems to overflow in memory, causes overflow which can cover adjacent data. And this can lead to memory anomalies, causing the system to crash. This is known as a fragmentation attack. Then reflection and amplification, right? With Smurf, it can perform reflection and amplification. You ping a broadcast address, and this leads to what's known as reflection amplification. When you ping a broadcast address, every device in the subnet responds to the victim. This kind of reflection and amplification. With DDoS, you can achieve this by masquerading lots of IP addresses and sending messages to occupy the victim's resources. With DDoS, you can use a lot of zombie machines to do the same thing. Of course, if you take it further, combining DDoS with reflection amplification, the threat becomes even more severe. The second type is control layer attacks. What are these? Like root injection or deletion, TCP hijacking, these are often control plane attacks, or called control layer attacks. How do they work? For example, imagine your network. Here is your network. And suppose I'm showing a simplified network. You have a router, below it a switch, and underneath a bunch of hosts. These hosts typically need to access the internet, access the public network. Now, a bad actor comes along, pulls a router out of his bag, connects it to your network, below it a switch, and under that, a bunch of hosts. Now these hosts underneath, they all need to access the internet through your network. The attacker then does something to your network. He transmits two routes to you. Okay, now here comes the bad guy. This bad guy takes a router out of his bag. He pulls out a router from his bag and connects it to your network. Then he does something to your network. He transmits two routes to you. One route is 0.0.0.01. The other route is 128.0.0.0.01. Simple, right? In your network, there's usually a dynamic router like OSPF or EIGRP. These protocols allow your devices to exchange routing information. He sends you routes like 0.0.00.001, 128.0.0.0.01. He injects these routes into your network. Normally, we access the internet using the route 0.0.0.0.00. We use the default route to access the internet. Now, with these three routes, considering the longest match rule, we have these three routes. The longest match rule means a longer prefix, like 1 instead of 0, is chosen over a shorter one. So, internet-bound packets will now match these two routes, which means your traffic gets misrouted. Effectively, your traffic is hijacked, redirected to somewhere else. And now, you can no longer access the internet. So what do? Even worse, what if he does this? He connects a host on his side, redirects all your traffic to it. He says, on his end, I'll just pull this off. He connects a host and pulls your traffic towards it. Or alternatively, he could, on his own attacker's host, set up routing protocols with your network devices on his attacking machine, establish neighbor relationships, and inject all these malicious routes into your network. He floods your network with these routes, these problematic routes, just like that. His routes just need to be a bit longer than yours. If you have a 24, he uses 25. If you have 16, he uses 17. If you use a default route, he uses 1. So, for some specific servers, he might inject 32 directly. So, he injects these routes into your network and diverts your traffic. In essence, he hijacks your traffic. This kind of thing is what's called route injection. So, route injection, that's what it is. Of course, there's a route injection, deletion, or TCP hijacking. These are often used to facilitate man-in-the-middle attacks. So-called man-in-the-middle, right? Your traffic gets hijacked. Honestly, once your traffic is hijacked, it's quite easy to detect. But what if he redirects the hijacked traffic, right? And then, acting as a middleman, he hijacks your traffic, coming to hijack your traffic. All the traffic you intend to send out passes through him. In such cases, he can basically do whatever he wants. This kind of attack is a man-in-the-middle attack. We say he can achieve this through route injection. Besides route injection, there are other ways to hijack, right? You need to know the next hop's MAC address. He just straight up claims he's the gateway. When you broadcast asking, what's the MAC address of the gateway? This guy says, I'm the gateway, here's my MAC address. Then, if the user believes him, he falls for it. His traffic will then be directed to the attacker, who is now believed to be the gateway. His traffic, thus, goes to the attacker. So this kind of attack, using forged ARP, can be utilized for attacks. Sure, can IP spoofing work as well? Yes, it can. And there's also traffic hijacking. How does traffic get linked? Traffic hijacking, for instance, can be done through certain specific protocols. It redirects the traffic, hijacking it. In essence, man-in-the-middle attacks are relatively covert. Especially for ordinary users, they are quite hidden. Because after hijacking your traffic, he can manipulate it, then send your traffic to the actual server. And then the server's response goes back to him. And then he forwards it to the user. At this point, he can extract or even alter some information. This is a man-in-the-middle attack involving ARP poisoning, which is ARP spoofing, just like ARP poisoning and DNS poisoning, right? That's ARP poisoning and DNS poisoning. ARP spoofing is actually ARP poisoning, and this is called DNS poisoning. Then there's IP spoofing, and these methods can achieve man-in-the-middle attacks. There's also DHCP spoofing, which is particularly vicious because it involves setting up a rogue DHCP server in your network, or what's called rogue DHCP, which means he deploys a DHCP server in your network, within your network, potentially just a laptop running DHCP service, or he might use a small router, like a home use TP link. And in this DHCP server, he sets the gateway to himself. Thus, your traffic, obtaining an IP address from the attacker's DHCP, will have its traffic routed through him. Your traffic is essentially directed to the attacker. This method, with a gateway at the attacker, ensures your traffic still goes to the attacker. This approach is just one of many ways they might use ARP poisoning, right? Through DNS hijacking, route injection, just as we discussed. This is route injection through DNS poisoning, ARP poisoning, IP spoofing, through rogue DHCP, or through other various methods, and other forms of traffic hijacking. So, through various methods, he can redirect the traffic to the man in the middle. Then he can carry out attacks. Speaking of which, deception attacks come in many forms. There are many types of attack forms you can implement. For example, when executing a DDoS attack, you can spoof source IPs, right? That's also a form of deception. Like, you can do it through route injection, right? By injecting routes into the network that are longer than the existing ones, you hijack the traffic by exploiting these injected routes. Or by methods like ARP poisoning, DNS poisoning, DHCP spoofing, etc. Any method that diverts traffic to the attacker is a form of deception. As long as it involves hiding your true identity, it counts as a deception attack. You can use these deceptive approaches to carry out DDoS attacks by concealing your identity, or to carry out man-in-the-middle attacks. Essentially, your identity is hidden to facilitate these attacks. All these are considered deceptive attacks because they often mimic traffic originating from other systems. thus concealing the attacker's real identity. Such tactics classify as deception attacks, not just one type of attack, but a means to enable various attacks while hiding one's identity. Through deception, you can facilitate DDoS, traffic hijacking, or man-in-the-middle attacks. These can all be carried out under the guise of deception. Source IP spoofing, for instance, is simply you pretending to be someone else by using their IP address. For example, if there's a host in your network at 192.168.1.100 and it goes offline, you can change your IP to 192.168.1.100, claiming to be that offline host. After it goes offline, the attacker can take on this IP and pretend to be the host that was previously online, thus allowing them to carry out further attacks. In this way, you can engage in various attacks by assuming another's identity. Indeed, why not? Of course, it's possible. Such tactics are known as IP spoofing. Furthermore, there's NDP reflection and amplification. Here we also mentioned a flooding attack earlier, specifically a DNS flooding attack. See here, this flooding attack and this DNS flooding attack are particularly nasty. Here it works like this. It's really troublesome. On this side is the UDP protocol. Unlike TCP, it doesn't require a handshake to establish a connection, making identity spoofing easier. You can claim to be anyone, and then, like with reflection attacks, the attacker swaps the source IP in the packet with the victim's IP, so the response from the server will return to the victim. Then all you need is to find a server to act as an amplifier. You find something to amplify your traffic, like the previously mentioned Smurf attack, which uses a broadcast address to increase its scale. Similarly, like this DNS amplification, how does it work? It's based on the DNS protocol, which works as follows. For example, with NTP amplification, there's a feature called monlist in the NTP protocol, where if your computer sends a monlist request to an NTP server, which synchronizes time, the server lists the last 600 IPs that synchronize time with it, sending back the information in packets, each packet detailing 6 IPs, up to a maximum of 100 packets for the 600 IPs. Thus, if the request packet is 200 bytes, and each response packet is approximately 500 bytes, this results in a 250-fold increase in traffic. This means that an attacker with a 1 Gbps connection could theoretically generate a 250 Gbps attack, overwhelming the victim's bandwidth. This is what's known as an NTP amplification attack, where a small amount of outgoing traffic can result in a large amount of incoming traffic to the victim. Thus, this type of attack amplifies the effect of the initial data sent. Such amplification attacks can significantly impact the target by flooding them with unsolicited responses, making them a severe threat in network security. In the case of NTP, if you use the victim's IP as the source, the NTP server will send all responses back to them, resulting in the victim's network being overwhelmed by the response traffic, maximizing the attacker's disruption capability. So, if you use the victim's IP as the source address and send a monlist request to an NTP server, you are essentially asking to retrieve the monlist. In this case, the NTP server will send back 100 packets to whom? To the victim. Considering each request packet is about 200 bytes and each response packet is roughly 500 bytes, this leads to a 250-fold increase in traffic. With such a mechanism, an attacker with a 1 Gbps connection could effectively generate a 250 Gbps impact, massively consuming the bandwidth of others. This type of attack is known as an NTP amplification attack, a kind of amplification where a small input from the attacker's side results in a large amount of data being sent to the victim, multiplying the traffic many times over. This type of attack is comparable to placing someone's number publicly and asking people to call it. Similar to pasting it everywhere, this amplifies the effect by leveraging a small amount of initial traffic to generate a significantly larger impact. Through this method, you achieve large-scale traffic amplification. NTP uses the monlist feature to achieve this, where a small query can lead to substantial traffic generation. This can overload the victim's bandwidth, essentially causing a denial of service. So, if you spoof the victim's IP and send these monlist requests to multiple public NTP servers, it directs the traffic back to the victim, overwhelming their network. This effectively turns a small amount of outgoing traffic from the attacker into a massive influx at the victim's end, overloading their system. Thus, the attacker achieves a significant disruption effect, a typical characteristic of a denial-of-service attack. This kind of attack leverages NTP's reflection and amplification potential, incorrectly referred to earlier in the discussion as a DNS hijacking, which is a different mechanism. To clarify, DNS hijacking involves redirecting DNS queries to a malicious DNS server, whereas NTP amplification exploits the monolist feature to magnify traffic. This detailed explanation helps distinguish between different types of network-based attacks, highlighting how attackers can manipulate protocols to disrupt network services and bandwidth. Such methods demonstrate the versatility and danger of network attacks. This refers to DNS poisoning. In the context of NTP reflection, NTP reflection is actually a type of amplification attack. We also have TCP hijacking, which is similarly manipulative in nature. It's not straightforward for TCP to differentiate these spoofed packets. So, what's the solution? The straightforward solution is encryption. Encrypting the communication would obscure the sequence numbers from anyone intercepting the data. Every packet in TCP has a sequence number which increments with each transmission, indicating ordered transmission. Now consider, if A sends a packet with sequence 100 to B, B might reply with 101, A responds with 102, and B follows with 103. This sequence ensures reliable, ordered delivery. However, if there's a pause in communication, an attacker could step in, impersonating one of the parties. A sends a sequence 100 to B, then B sends 101 back to A, then A sends 102 to B, and B sends 103 back to A. Through this ordered sequence, the transmission continues seamlessly. But suddenly one side stops sending new messages temporarily. At this moment, an attacker comes in and continues the sequence to communicate with one of the parties. The attacker would, of course, need to forge their IP to match. In doing so, they effectively hijack the connection. Thus, without the need to validate packet authenticity, the attacker can intercept and manipulate the communication. This act is a form of session hijacking, where the attacker impersonates one of the communicators midway. This is essentially what TCP hijacking involves. Therefore, it's critical to understand that deception attacks can vary widely in their execution. However, all such attacks, like reflection amplification attacks, rely on exploiting the predictable behavior in communication protocols to manipulate and amplify harmful actions. For example, using the monolist function in NDP reflection attacks allows attackers to amplify a small amount of initial traffic into a massive volume directed at the victim, similar to how spamming systems operate. This comparison is akin to using someone else's phone number to sign up for multiple services, resulting in a barrage of unwanted messages. Thus, reflection amplification is a serious security concern that exploits and magnifies the reach of the initial attack. Reflection amplification is essentially a feeling like this. As for the Smurf attack, we just talked about it, right? The Smurf attack, it is faking this. The attacker fakes the victim's IP, that is, he goes to broadcast. Then, others respond, and all the responses go back to the victim. In this case, the larger your network segment, the better the effect. For example, if you have a 24 network segment, right? That is, if you have a 24 subnet, in this case, he just multiplies by more than 200 times. He just can amplify up to more than 200 times. But if you say some people are lazy, they have longer subnets, you say, let's have, say, something like a 21 or a 20. In that case, one can only say, right? The effect is outstanding, just like this. Of course, now, with new Windows systems, they by default, in the firewall, have ping disabled. That is you. You open the control panel, there's the firewall. If your firewall is by default turned on, it is if you don't do anything. It is prohibited. If you try to ping, it will not respond. In this way, to a certain extent, it can alleviate the Smurf attack. So, your computer, right? won't easily be used by others as an amplifier. That is, your computer won't easily be used as an amplifier by others. This is a Smurf attack. Besides these, aside from attacks using these technical means, what else is there? This stinking social engineering. Online, there is a database called the Social Engineering Database. The Social Engineering Database is essentially often filled with what? Some information that has been leaked. Inside, it contains some of this leaked personal information, right? How does the Social Engineering Database come about? Through social engineering. Through this kind of social engineering, it's constructed through so-called social engineering, which is done through legitimate communication with others or by gathering some information. It's like out of nowhere, right? Just like, for instance, say you work in a sensitive department and then someone comes to cozy up to you. And then it's like, for example, right, they ask some seemingly insignificant questions. Just like, for example, for instance, right, it's like, ordinarily, do you ever take your kids to school? Stuff like that. He might just know do you have set working hours or anything like that. For instance, let me give you an example through this kind of some legitimate interactions and then, or some extraction of some secrets. Then in this case, you can, through these personal legitimate interactions, of course, you can through something like what? Through some information like what? Delivery slips, right? Through a delivery slip, where someone leaves their name, their phone number, for instance, through you, through other people's, through some forms filled out by others, right? And then you sell people's personal information. In general, the most bribable link in the entire information security chain is people. In this way, social engineering, it utilizes this weakness of people thus to engage in some kind of illegal activities. In this case, it's not just about intruding into our computer systems. So, here it is to say, this kind of social engineering, honestly, is very hard to defend against because now, right, that nowadays, a lot of personal information is almost like being naked domestically, right? Domestically, I believe everyone has received harassing phone calls. So, in this case, how do you defend against it, right? Honestly, this thing is really indefensible. You say a broad credit card fraud, right? This thing is also very serious, also very severe. This thing, so no matter where, this thing, you can only say, right, it's just as long as there are people around. There's a possibility of this kind of threat that is the most bribable link in the entire security chain. Is people. That is, social engineering uses this vulnerability of people to carry out attacks. In this case, you say what to do, right? Then you can only do this through some technical controls. Just like, right, something like identity recognition, that thing is just, what does it mean? Just through various methods to limit some behaviors of people, right? Like through a nearby identity recognition system. That is, this person, right? Do they have permission? Does this person have permission? Or what this person, or say, this person's flow? The traffic initiated. Is it allowed or not allowed? Is it allowed to pass through a certain firewall? Or say, right, we use encryption, right? This person, can they still decrypt it? Using various ways. But honestly, right, no matter how much you do, there will always be, no such thing as a completely airtight wall. There will always be definitely those people who inadvertently, in some way, let some secrets slip out. Like what? For example, I remember before, right? There was a person, he put a password, right? On that CSDN site, I remember, this sparked a series of events, caused a series of database scraping incidents. That is, scraping databases, not that type of database. This is scraping, right? Credential stuffing, this term. Scraping means you pull out data from someone's database. Then, what does credential stuffing mean? It means for example, you extract data from a website's database, seeing usernames and passwords. Then you use the same username and password to test on other applications. That is credential stuffing. What about scraping and credential stuffing? Honestly, right, then you just say you say, are there such things? Some people are lazy, they tell others their account passwords, this will happen, right? So what to do about this, right? Honestly, this is just, relatively speaking, it's troublesome. This thing is just people. right? There will always be some kind of uncertainty. That is to say, so if we don't include this human factor in this security management, you will leave a big loophole, right? Here, it's not just through technical means, but also through some institutional solutions, including things like phone scams, phishing, including this kind of tailgating and tracking, and stealing some critical, like key thefts, critical devices, right? Or that peeping, right? These are all considered. Just say someone's typing a password, you're watching from behind. Does this count? This kind also counts, right? Say phishing, you go phishing, you send someone a link, right? Telling them send someone a link and tell them they have points for a free order, exchange for something. Then after they go to your webpage, they really want to go to, let you ship, right? They fill in their personal information. They send their personal information, right? Is this the case, right? This is phishing. Even, right, he creates a fake login page for you. He steals your username and password. You mentioned phone scams, right? Honestly, this thing, well, no need to mention it anymore. This kind of thing, including others, basically these things are also some of those kind of underhanded tactics. These are common social engineering attack methods. Why do I say social engineering stinks? Because it always involves some sleazy tricks and then doing some illegal activities like leaking personal information, which is already annoying enough. So this thing can only be described as hard to guard against when it comes to social engineering. That, in this case, you could also consider it an attack. Then, next, there are password attacks. Password attacks, these are specifically targeting your password. And these passwords, well, for example, guessing. Honestly, right, guessing, some people, I guess your password is what? Like, right, one person, he finds a wallet, he throws out the bank card, throws out the ID card, he says, I'll try if your password is your ID number. What kind of guessing is this? And brute force cracking. The exhaustive method, like if you find a suitcase and don't know how to open it, what do? You try from 00 to 999. This is called brute force cracking. This is the so-called exhaustive method, right? Next, dictionary attack. What is a dictionary attack? A dictionary attack is also a type of brute force attack. It builds a dictionary of common passwords he believes in, or could use the exhaustive method to include common passwords in a specially created database, then tries them one by one. In this case, trying one by one is called a dictionary attack. This kind of dictionary attack, honestly, is typically targeting all character combinations, is less common. Like if it's an 8-character password, all numeric letter character combinations. If you calculate all these, attacks are less frequent. Like for example, that if it's 8 characters, you calculate all possible combinations of numbers, letters, and characters. That's also 8 characters. If you calculate all the combinations of numbers, letters, and characters, the dictionary you generate should be at the database, DB level. With such a huge dictionary, when will you finish running it? Honestly, this is why dictionary attacks usually use some common passwords, like what foreigners like to use, things like PAT55, WORD, right? These types of passwords are especially favored by foreigners. What are the most popular passwords among Chinese people? Things like 123, 23456, and the like. These kinds of passwords, right, are favored by Chinese people, like 123, 1233456. This is this thing. Such passwords are very easy, right? Very easy to be targeted by dictionary attacks, like some sequences on the keyboard, like QW212ASDF, like these, right? You hold down the shift key, first row, then release the shift key, second row. These types of passwords, right, are definitely going to be included in someone's dictionary. So this is what a dictionary attack is about, using common password combinations, building a database, and through this database, run them one by one, eat up. And this kind of thing is a dictionary attack. Apart from that, there's something called password sniffing. For example, right, like he gives you, say someone, right, he installs next to your computer a secretly installed camera. Then, when you enter your password, he captures it. In this case, about passwords, what is that? This is password sniffing. Like when you enter on a keyboard, for instance, you're like some kind of access control keypad. He looks at which letters or numbers are more worn out, then goes on to try to crack your password. So these kinds of password attacks generally include things like guessing, right? Of course, obtained through social engineering, right? Like some social engineering databases are used to find someone else's information from others, like say an app's database was hacked, and then you get someone's password from an online social engineering database, and then you try to breach databases, right? This is also considered guessing. Then he goes to use your brute force exhaustive method. This attack is also similar to the exhaustive method, just a variation of it. Password sniffing involves various methods, right? Like using a hidden camera or spying nearby. In such cases, right, for example, say there's a pickpocket on the subway who watches you unlock your phone and sees your password, then he steals your phone. Then he goes your, he uses your account, right, to buy virtual goods and then sell them to others, like in this way. This kind of case could also be considered password sniffing. That password attack, in such cases, how do we solve password attacks? We need to implement some password strategies, like the simplest is to increase the complexity of the password. Increase the length of the password, right? This is the simplest and most brute force method. Then you use more character types, like requiring uppercase, lowercase, numbers, characters. Try not to use some of these simple passwords, just those especially simple ones. The less logical your password is, the harder it is to crack. The best would be those nonsense-like things, like those randomly generated passwords. Honestly speaking, right? Honestly, those are very hard to crack. Like your home's optical modem might have a Wi-Fi password set by the telecom, right? That password, if you write it down, you mention like those kinds of passwords. Once you write them down, right, you can use it. And honestly, it would be very hard for others to crack your Wi-Fi. Such random things are very hard. Like if you say you want to go to some apps, right? Like when registering an account, if your password is randomly generated, then honestly, it's also very hard for others to crack it. It's very, very difficult to break through a dictionary that typically won't include such gibberish. If you put gibberish into it, the dictionary would become very, very large. It's just not feasible to use it. So, about cracking passwords, one aspect is password strategy. Preventing password cracking is one strategy. Another is setting up like the expiration of passwords, how often you need to change your password, requiring password changes periodically. Also, like some apps will require after you enter your password incorrectly, after you enter it wrong, you wait a minute before trying again. If you get it wrong again, wait 2 minutes before trying again. And if it's wrong again, right, wait 4 minutes before trying again. Every time you do this, it will also lead to these like brute force and dictionary attacks not achieving their usual effectiveness. But this approach is also a double-edged sword. For instance, right, if someone deliberately keeps making you enter it wrong, they could end up disabling your account. Just lock your account. Your account gets disabled. There was a case before. I remember there was one. I saw a post online. It said that he was worried his wife would spend money carelessly. Every day he would intentionally enter the wrong password for his wife's account several times. Then his wife couldn't use it. Honestly, this means that some password strategies can indeed be a double-edged sword, just like I just said, right? You say, after entering the password, how long should the account be locked? This kind of thing is a double-edged sword. So many apps out there don't implement this mechanism, right? They might ask you to verify by some method instead. They won't just lock your account after a few incorrect inputs. For ordinary apps, they won't do this. But overall, we need to use some password strategies to guard against such types of password attacks. But generally speaking, these are the strategies we use to prevent these types of password attacks. Okay, it seems we've inadvertently reached 9:30. Okay, so for today, we probably won't finish all this. Let's stop here for now. Does anyone have any questions? If you have a question, type 1, because I know you might have questions and might not type fast enough, right? I will answer them before ending the class. If you type 1 indicating you have questions, I will finish answering before ending the class. If there are no questions, then we will end the class. Okay, let's end today's class and continue in the next session.